have instituted no patient dumping laws. So these laws basically ban hospitals from sending patients away. So imagine a case where a private hospital receives a patient that is publicly insured. So that private hospital cannot send the patient away. It has to provide that urgent treatment. So you can think from a policy maker point of view that such extensive private networks can also facilitate the timely access for patients in need from other networks, in particular from the public network, and that may also increase efficiency and quality. However, those efficiency gains and also cost gains may depend on the strategic behavior, on possible strategic behavior of patients and providers and hospitals. So this is what we examine in this paper. So we ask kind of 3 questions. So first, whether there is strategic behavior of both hospitals and patients in this setting, in the setting of emergency care that is covered by anti-dumping laws. So we are going to present, I hope, convincing evidence from reviews from analysis that is the case, that there is strategic behavior on both sides. Then we want to ask what are the associated costs to that behavior, to strategic behavior. So we are going to model the behavior of both hospitals and patients with the structural models. And finally, if I have time, so I'm going to show whether this strategic behavior, mainly of patients, lead to better patient outcomes, which is to say whether patients when they go to a private hospital, they are better off afterwards, right? So as I mentioned at the beginning, so this is kind of, not super preliminary, kind of preliminary. So feedback is very helpful. So let me tell you briefly about the institutions. So in this paper, we're going to examine the situation in Chile. So in Chile, 20% of the people are insured within private insurance companies, and 80% are in the public sector, right? There is a separation usually between income, so higher income people in the private sector, and each insurance network has different hospitals. Right? So there are public hospitals and private hospitals. So in this case, we study, as I mentioned earlier, people in the public sector that go to a private hospital for emergency care, and this is emergency care in a life-threatening situation, right? So think of a heart attack. So so the public insurer covers fully this we call them out-of-network visits, right? Because these are patients that go to a different network for attention. So given this fully reimbursement from the public insurer, so the providers have at the margin have the incentive to provide more care, right? To be reimbursed more. So this is going to be like the first part of the paper. I'm going to be more detailed in a second. And then the patient, after the patient is stabilized, right? So they ask him or her whether the patient wants to be transferred to a public hospital or stay in the hospital and pay like the full price. And that depends on the capacity of the public system to transfer him to a public hospital. So this is going to be the second part of the paper, because in that case, the patient has incentives to kind of lie, not to state his true desire, right? So that's going to be the second part of the paper I said. It's going to be more clear in a few slides, I hope. Let me tell you briefly about the data. So basically, we have data on all these out-of-network emergency visits. We have patient characteristics. We have data on the hospital, and also what happens with the patient afterwards. And for the sake of time, I'm going to skip some things. So I apologize for that. And the last point I wanted to mention is that these visits are expensive. So on each of these visits, out of network visits, last 8 days on average and cost 6 times of the per capita budget allowed for healthcare. So and it's also twice as expensive as the equivalent episode in Medicare in the US. So these are expensive visits, and the Ministry of Health in Chile is concerned about this cost. Okay, so this is what I said before. I'm going to show you a flow diagram in a second again. But basically, the first part of the paper is going to study since the patient's arrival to the private hospital to the moment of his or her stabilization. Stabilization is the moment in which the patient is ready to be is ready to be transferred. So we call this the pre-stabilization. Then the second part is post-stabilization, when the patient since the stabilization until the patient is either transferred to a public hospital or discharged from the private hospital. And then the third part of the paper studied the effect of basically this on outcomes, on health outcomes. Great. So let me show you the data, how the data look like briefly. So the plot on the left show distributions of the expenses, both for pre-stabilization and for post-stabilization. So on average, pre-stabilization visits are more expensive. On the diagram on the left, or the right, sorry, you can see the length of stay. So these hours of stay. So you can see that pre-stabilizations are much shorter, even though they are more expensive, as I showed you in the previous plots. And post-stabilization can last, it has a heavy tail to the right. So patients can stay in the private hospitals forever, quote unquote. Great. So for some visits, we have this we have the total expense of the visit, right, in general, but for some visits, we also know how they divide. So for example, you can see that a little bit more than 35% of the total expense goes to bed expenses, right? So then you can see tests, supplies, medicines, and so on. Right? So I'm going to focus on beds in this talk, at least in one part of the talk. So this is the flow diagram I promised you earlier. Basically, this is the patient has a heart attack, suppose, close to a private hospital. So then he goes to the admission, right? To the emergency department admission, right? And then he stays there until the moment he's stabilized, right? So this is the pre-stabilization. Then, a number of things happen in the second stage, which I'm going to talk about them later. So let's focus for a moment on the pre-stabilization. So we want to ask whether hospitals respond to this reimbursement by the public insurer, and how. So this is we have two pieces of evidence, of kind of reduced form evidence. So the first evidence is a discontinuity at midnight. So this is the hours around midnight, and this is the total expense. This is the residualized expense, right? So that's why you can see the average is 0. So you can see that at midnight, the expenses, there's a spike at midnight, right, on expenses. And most of this jump happens due to beds. So we kind of infer that when the patient stays after midnight, so then the hospital charges the private hospital charges the public system a fixed amount, right? So you see that the expense here is around half of this jump here, right? So, okay, so this is like kind of the first stage. So hospitals are paid more if the patient stays in pre-stabilization after midnight, okay? So then the natural thing for a hospital with a strategic behavior is precisely what we see in these other plots. So this is a histogram of patients that are stabilized at different hours in the day. These are half-hour bins. So we see that throughout the day, I mean, this is like afternoon, towards the evening, the share of patients decrease, the share of patients that are stabilized decrease, and then suddenly at midnight, we see a spike, right? Which is consistent with the fact that hospitals are paid more just after midnight. And then we see a drop again, right? And then in the morning, an increase. So this is to say that more patients are stabilized at midnight when hospitals are paid precisely more in a discontinuous way. And then also those patients that are stabilized right after midnight also stay for more time at the hospital. So you can say that they spend the whole night, right? So once, I mean, a patient that is about to be stabilized at 11:35, then they push him to be stabilized at 8 a.m. Right? So this is kind of the behavior we see here. And then the hospital, of course, is paid more, as we saw in the previous plot. Okay, great. That was the first evidence. Then the second evidence that hospitals respond to payments from the insurer is due to a reform that happened in December 2015, where these payments to private hospitals was increased through there was a decree by the Ministry of Health that changed the composition of payments. So when we run the regression, this is again kind of the first stage. We run the regression of expenses on time stay. So the coefficient of that regression is kind of the average payment, right? So we see that precisely in December 2015, kind of January, the first quarter, we see also an increase in that price per hour, right? This is the first stage. And then this is the reduced form. So this is what we see. So this is the average hours that the patient stays in pre-stabilization. So we also see that the number of hours that patients stay increases. This is, again, sorry, the residual, right? That's why this is 0. So after, in 2016 and after 2016, the number of hours that patients stay in pre-stabilization increased by about 2 to 4 hours, right? This again, our reduced form. When we run the IV in tables that we don't show here, this implies an elasticity of expenses with respect to length of stay of 0.4. This means that if payments increase by 1%, then patients stay in pre-stabilization 0.4% more. Okay, so this is like the other reduced form evidence we have for strategic behavior in pre-stabilization. Okay, so now that we show this, what do we do? Basically, we want to calculate the implications for strategic behavior on cost, right? So this plot on the right shows this is the expenses, and these are on the x-axis the number of hours, right? So this is how many hours patients stay, right? However, we see this as kind of an equilibrium object, right? Think of this this is a demand and a supply curve. We call them a reimbursement curve or a revenue curve, which is how much the public hospital pays the private hospital. And also you have another curve, which is the strategic reaction or cost of the hospitals. So then these things, the point in which these two curves cross, it determines the equilibrium that we see here, right? So we need a model or some exogenous arrangement to separate out these two. So we are going to use what would also especially what I showed you earlier, like this reform, kind of to separate like the effect of these two curves. And excuse me, I'm going to skip this slide for a second. And so this is going to be this is the revenue curve. This is going to be a cost curve, right? So if the revenue curve changes, then the quantity is the equilibrium quantity is going to change, right? So we are going to be able to identify the cost curve, right? So in equations, so we are going to model the revenue as a two-part tariff, and there's a fixed part and a slope. This kind of reminds of this curve, right? So we see like kind of the equilibrium hours of stay and expenses looks like a two-part tariff. It's also pretty linear. So we're going to zoom this. Also, we are going to introduce a lot of heterogeneity, right? So these are going to be random effects and so on. But for the model, I mean, let's assume just a pure linear curve. Then profits are going to be the hospital profits or utility, right? Are going to be like the revenues minus hospital costs. So these costs include both, you can think of those as costs of the hospital themselves, but also the cost of patients. So the hospitals are not going to set the number of hours to 0, right? Because the hospital interiorizes also the cost of patients.
7 minutes, Jorge.
Great. So then if hospitals maximize this utility function, then we can back out the equilibrium hours the hospital gets. We have preliminary estimates. Now we are trying another estimation with a simulated method of moments that we haven't finished. But basically, once we estimate the system, we can change this revenue curve and, for example, model the situation where the revenue curve changed from this curve to a new curve, right? So we can, and also this is like the policy motivation. So the Ministry of Health in Chile is actually thinking of doing this change. So we can tell the Ministry of Health how much outcomes are going to be impacted and how much costs are going to be reduced. So our preliminary estimates show that changing this curve to a fully kind of fixed payment, sort of eliminate the slope, saves the payer cost 18%, and while leaving providers indifferent. So I'll be happy to talk more about how we do this counterfactual exercise, but I don't have time right now, so sorry for that. But basically, this is the direction towards that we are working on right now. Great. So let me tell you briefly about the second part. So patients, once they're stabilized, have to choose whether to be transferred to a private hospital, this part here, and pay the fully OON rate. So this is the fully out-of-network rate, which is very expensive, or choose to be transferred to a public hospital. But the problem here is that even if the patient chooses to be transferred to a public hospital, and then he ends up paying a low price, then the patients, there is a probability of the patient actually being transferred to the public hospital or not. And this is a probability coming from the capacities in the public sector. So you can see that 90% of patients choose to be transferred, but then only 20% actually ends up being transferred to the public, right? So 70% are actually discharged from the private hospital. So this kind of suggests a strategic behavior on the part of patients, right? Because they end up paying a low payment, but they enjoy the benefits and the quality of the private hospital. So to model this decision, we also built a structural model of patient's choice. The model under some assumptions is going to be, we're going to estimate this as a logit model, where, so this term here is the expected cost, so of the patient's stay. And the second part is the expected gain in patient's utility, right? So we have here the expectations of the time that patient stays in the hospital times the probability that the patient is transferred. And this term here is the patient's utility for the private hospital. So basically, it's estimating this demand model, this logit model, we can recover the patient's willingness to pay for the private hospital. So how much they value the private hospitals with respect to the public hospital. So then what we do is we parameterize this term UP as this function that depends, well, on a kind of a subjective measure of utility, which is the Google star rating of the private hospital, and also some objective measure of quality, that is the mortality at the residual mortality in the private hospital. So why do we do this, or where does the identification of the model come from? Let me show you this plot here that shows this is the transfer rate of the patient to the actual transfer rate of patients in the public hospital to the private hospital, and this is the no transfer request, so the request to remain. So we see in the data that when there is more transfer to the public hospital, then patients request to remain, right? So then basically they kind of know, they infer what is the transfer rates, and according to those transfer rates, they respond accordingly, right? So when there is very little transfer, they request to remain, they request to be transferred, right? So because they know that they are not going to be transferred, but when they actually are transferred, then they request to remain in the private hospital, right? And they end up paying out of pocket. Fantastic. The estimation of this model, again, we are still, so a preliminary estimation shows that kind of the parameters have the expected sign. So patients value both the Google star ratings of the private hospitals, and also they value the lower mortality of the private hospitals. Right? Now we're introducing random coefficients to allow for more unobserved heterogeneity. And let me show you in a minute the third question. So the question is whether patients that spend more time in the private hospital have better outcomes. So we used an IV strategy, which is precisely the capacity of public hospitals, basically to receive them, because that moves the transfer rates. And we see that indeed that patients that are transferred to public hospitals have a higher complications associated to them. So we use here the dependent variable is these complications, right? So reinfections, readmissions due to infections. And I'm going to stop here. So just to summarize, so in this paper, we studied the strategic behavior of hospitals patients. We provide both reduced form evidence and structural models of behavior on both sides. And we also show that patients that private hospitals basically provide benefits to patients. And also this leads to policymakers to ask the question whether it should be worthwhile to basically to extend this private network, right, to care for patients in public sectors. Again, thank you very much.